global pandemic novel coronavirus, which we know as COVID-19, is still involved in Malaysia. According to the data analysis from Statista, the number of daily cases confirmed in Malaysia is increasing starting from October year 2020 until now, which already stepped into July year 2021. The greater number of confirmed cases means that the usage of bed in quarantine center will be higher, which we can always heard about. The capacity is full in few of Malaysia quarantine center in this couple of weeks. According to a report from Channel News Asia (CNA), the quarantine center in Serdang should be only occupied 60 patients in category 3, but on 16 May of year 2021, they already overloaded the bed to around 755 patients. This means government need to purchase more bed to handle the huge number of COVID-19 patients, so that government already spent over million ringgit of expenses for buying bed in quarantine center. However, here is another problem has arose: how the government should handle the bed after the pandemic. Are they going to discard them, which will lead to the environmental issue, or the bed will be donated to the people who in need? With all these uncertainties, it inspired and motivated us to design a medical bed that can use in both quarantine center and also the hospital, not only to avoid wastage but also to reduce the annual expenditure of government that has spent to purchase the healthcare facilities. And the bed we designed is called the Compact Self-Warming Bed CSW Medical Bed. The objective of our product is to design a durable, space-saving, portable, and cheaper CSW medical bed. Not only that, we also want to design regulated warming CSW medical bed. Lastly, our objective is also to design a multi-purpose usage medical bed during emergency. Our product is also fulfilled goal from Sustainable Development Goal set by United Nations, which we call SDG. The first SDG achieved our product is SDG number 3, Good Health and Well-being, which will ensure healthy life and promote well-being everyone at all age. The second SDG achieved is SDG number 11, which is Sustainable Cities and Communities, which makes cities and human settlement inclusive, safe, resilient, and sustainable.
The following shows the drawing of the bed frame in extended form. The dimensions for this form will be 2100 by 980 by 460 mm. This is the assembly drawing of our CSW medical bed, which will be explained further in the next video. This is the closer look of our CSW medical bed in extended form. At the bottom side of the bed frame, we have installed a self-heating system which is hidden along the hollows of the aluminum channels. Thus, it will not look messy with cables hanging around. Then, we place a mattress on top of the bed frame, which consists of 4 small mattresses combined. This CSW medical bed also have rail guard to prevent the patients from falling out of bed, foldable legs that can be rotated 90 degrees, and wheels for easy mobility. After gathering the information, we have modified the existing medical bed into CSW medical bed to solve the current issues as mentioned in the problem background. For example, we have installed a fully automated heating system on our medical bed to solve the problem of high air conditioning in the hospitals. When not in use, the CSW medical bed can be fully collapsed into the width of 200 mm. Not only that, our CSW medical bed can be transformed into a stretcher. When it is in a stretcher form, the bed will be collapsed into the width of 520 mm and 2 of the small mattresses will be put together. With this design, we have achieved Objective 3, which is to design a multi-purpose use of medical bed during emergency. This is the detailed drawing and dimensions of the frame in stretcher form. Next, we have the drawing and dimensions of the frame in bunch form. Lastly, this is the drawing and dimensions of the mattress, which consists of 4 small mattresses combined together. Next, we will further discuss about the working principle of CSW medical bed in the next section.
The overall design concept and the working principle of our bed frame is greatly inspired by the working mechanism of the collapsible gate that are usually installed at the source. The bed frame is fabricated from vertical pieces of aluminum channel spar to provide the shape. Then, we use the double bar pantograph, that is the mechanical linkage connected in a manner based on parallelograms, which form the X design to fill the gap in between the vertical channels to reinforce the design. The double bar pantograph and the channels are held in place using fixed and movable rivets. With this kind of design, the bed frame can be freely closed or open. The next video will show you how this can be done. This is a demonstration of working mechanism between a set of channels. With a slight push, the bed frame is collapsed into a smaller size, and with a pull, it is extended. It can be closed partially to become a structure. The bed mattress at both sides are detached to match the size of the structure. When the double bar pantograph is collapsed, the heating cable filled in the gap perfectly. This is the circuit simulation of the self-heating system. This is the code of program that runs in C++ language. Now, let's start the simulation. When the temperature is set at 25 degrees Celsius, the heating cable is off. When the temperature drops below 22 degrees Celsius, the relay closes the circuit and the current flows to generate heat. The heating cable is on. Green LED is lit up as an indicator. When the temperature is adjusted to 28 degrees Celsius, it is beyond the ideal temperature. The relay opens the circuit and the current stops flowing. Red LED lights up. The heating cable is now off.
For the material selection part, for the bed frame, the material that will be used is aluminum alloy 6061. This material application can be observed in various fields such as automobiles, aircrafts, marines, and defense. Aluminum alloy 6061 has a density of 2.7 gram per cubic centimeter, while mild steel has a density of 7.85 gram per cubic centimeter. This shows that aluminum alloy 6061 is lighter than mild steel. The weight factor is very important because people need to carry it when emergency happen. Secondly, the heat conductivity of the material is also an aspect to consider, as the bed frame that will be produced is equipped with a heating system at the bed frame. Aluminum alloy 6061 has a thermal conductivity of 180 watt per meter Kelvin, while mild steel has a thermal conductivity of 51.9 watt per meter Kelvin. This proves that mild steel has a much lower conductivity than aluminum alloy 6061. If the material that will be used has lower thermal conductivity, then the efficiency of the heating system will be lower. Therefore, aluminum alloy 6061 is a suitable material for the bed frame, as it will increase the efficiency of the heating system. The material of the mattress is based on food-grade polyethylene foam PE. PE is a process format of many disengaged small air bubbles, and the most common type of food-grade PE is the high-density polyethylene foam HDPE, and it does not contain dyes, other additives, or recycled plastic products deemed harmful to humans. Environmental groups across the globe have recommended the use of food-grade PE as a safer plastic option. Crib mattresses made from food-grade PE is now becoming the top choice among parents due to its antimicrobial properties, non-toxicity, flame retardance, high thermal conductivity, and water resistance. Therefore, the food-grade PE would be an excellent material as a bed mattress, especially for our patients, as they have to lay on the hospital beds most of the time. On the validation of our compact self-forming medical bed, We conducted a quantitative survey using rating scale method through a Google form to seek for feedbacks and opinions on our product, where in the form we included the design of our product and explained clearly the details of our product and how it works. A total of 100 people participated in this survey, where 62% rated 5 over 5 of the overall design of our product, 30% rated 4 over 5, whereas the remaining 8% rated 3 over 5. For the functionality and purpose of our product, 65% rated 5 over 5, 32% rated 4 over 5, and 3% rated 3 over 5. 64% of the respondents extremely agreed that we'll be able to achieve our objectives by rating 5 over 5, while 30% rated 4 over 5 and remaining 6% rated 3 over 5. It can also be observed that 86% of our respondents agreed that our product is feasible to be utilized at COVID-19 quarantine centers and at hospitals.
While designing our medical bed, there are several health and safety considerations that we have implemented in our design. Since we have installed a fully automatic heating system in our bed, so there are potential fire hazards that we have to consider, such as overheating. Therefore, we have made some modification in our heating system to further improve the safety of the system. By using the same code, another temperature sensor is installed to measure the temperature underneath the mattress. When the temperature under the mattress is 50 degrees Celsius, warning message is shown. The power supply of heating cable will cut off abruptly, while the red and the blue LED is light up alternately. The emergency alarm is triggered. Potential fire from the overheated system and mattress can be prevented. Other than that, we also did not forget the HSE considerations on other components of the bed. For example, we have selected food-grade polyethylene as the bed mattress material, as they can withstand high temperatures. The use of high-quality flexible carbon fiber heating cable that can withstand over 5,000 times bend. Installation of belt on the stretcher to fasten the patient when evacuating. And lastly, the installation of the rail guard. Safety factor. This design managed to get safety factor of 4.08 for 90 kg load, which is good. This means that this design can reduce the possibility of failure. Von Mises stress. The maximum stress that this design can withstand for 90 kg load is about 50 megapascal. The add structure here helps to increase the strength of the design. Displacement. For 90 kg load, the maximum displacement of this design will be about 0.03 mm. The maximum displacement will occur at the center as there is no support underneath the frame. Thermal distribution. When the heating system is operating at 30 degrees Celsius, the frame will experience temperature of 29.88 degrees Celsius. This shows that the material used as frame has a very good thermal conductivity. Because of this, the efficiency of heating system will increase.